If you look in your notes on page 10, you'll see that I'm doing question number 2 from page 10. The first step says to rewrite both sides of the equation with the same base. Now, right now, we can see that our base is a 9 and our other base is a 3. When we are rewriting using the same base, we like to usually try to use a smaller number, and let me explain why. So, for example, over here, if I have the choice between the 9 and the 3, I would try to pick the 3. It's a smaller number. And again, I'll explain a little bit further. So what I mean by that is this. So if I keep a 3 as the base, then obviously the right side of my equal sign is not going to change. Now here we go. So if we look at the left side of the equal sign, my base is a 9. So what I want to try to do is make that 9 a 3. And the way I can make that a 3 is by making that 3 squared. Now think about that. 3 squared is equivalent to 9. So I haven't changed the value of 9, I've just changed the look of it by making it 3 squared. It's still the same value. And I want to do that because I want to have the same bases. And you'll find out why I'm going to do that in just a second. All right, so then I've made 9 into its equivalent value of 3 squared. And then I can't just forget that x plus 1. So what I'm going to do is I'm going to bring it down, and I'm going to just put it in parentheses like that. So x plus 1 in parentheses. Okay, so now if you look at this equation, the left side and the right side are really the same exact thing. The only difference is I replaced a 9 with 3 squared, which again is an equivalent value of 9. Okay, so then you look at step 2. And if you look at step 2, it says to cross off the bases. So once you get, this is why we were trying to keep the bases the same. Once you get the bases to be the same, we just cross them right off like that. Okay? And then if you look at the next step, step 3 says solve the equation with the remaining exponents. So what I'm going to do is I'm going to take the exponents, so I'm going to take the 2 times the x plus 1 and set it equal to the exponent on the other side. So really all you have is an algebraic equation, and now all you're going to do is solve. So if you get those bases to be the same, you can cross them off, and then you're just treating the exponents as an equation. All right, so then let's keep going. So we're going to get 2x plus 2, because I'm going to distribute that 2 through, equals x. Then I'm going to subtract x, and when I do that, I get x plus 2 equals 0, and I'm almost done. I'm going to move that 2 over and subtract it. Okay, those will cross off, and I will get x equals -2. And there's my answer. Now, if you look at step 4, it says to check in the calculator. So basically what you're going to do is I'm going to go back to the beginning here, and I'm going to write 9. Now I know my x is -2 plus 1 equals, and then over here, 3 to the, and again, I know my x is -2. Well, this is 9 to the -1 equals 3 to the -2nd. And you can plug this into your calculator, and you just want to make sure that the left side and the right side equal one another. Okay, so over here I get 1/9, and over here I get 1/9. So then I know that everything is good. So looking at number 3, we're going to do the same thing. So we want to rewrite both sides of the equation with the same base. So now in the last question, in number 2, we went for the smaller base, which is what I would like to try to do here, but let's look at this. So I have a base of 32, and I have a base of 4. Here's the problem. 4 would be the number I would like to use. However, let's think about 32. 4 to what power will give you 32? Try that in your calculator. Try 4 to the 2nd, you'll get 16. Try 4 to the 3rd, you'll get 64. So it just skips right over 32. So that doesn't work for us. So what I'm going to try to do in a case like this then is not to panic. We're going to try something even smaller than 4, which would be a 2. So let's try 2. And we would just try 2 to what power will give me 32. And that ends up being 2 to the 5th. And you can try that in your calculator. 2 to the 5th You plug that in, you'll get 32. And I'm just going to bring down that x equals, and then on the right side I'm going to make the 4 also 2 to some power. So 2 to what power gives you 4, and that would be 2. Okay? All right, so then that is step 1. Now we're going to do step 2, which is cross off the bases. Step 3 says solve the equation with the remaining exponents. So in other words, well, we know that 5 times x is just 5x equals 2. We set those exponents equal to each other, and we just solve algebraically. And we will get x equals 2/5. And there's your answer. All right. Again, you want to make sure that you do a check. So we go back to the original equation. We have 32. Now I know x is to the 2/5. Okay, equals 4. And then you plug that into your calculator, and you will get 4. All right, so turn the page, and let's look at number 12, and we're going to do the same thing again. So this one is interesting because we have a fraction as a base. But let's look at this number here. Our base is 216. And over here, our base is 1 over 36. Sometimes what I tell my students to do is they freak out when they see that fraction. I say just try to ignore the numerator for a second. Just bear with me. If you ignore the numerator, then let's pretend like this is a base of 36 and this is a base of 216. Now you want to try in your calculator. Remember, we usually try to go smaller. And let's say I'm going to try 36 as my base. Well, let's go over here. And can you do 36 to any power and get 216? And you'll find out that you won't. So what you want to do then is go smaller. And I think 6 would be a really good place to start. So I'm going to try 6, and when I do 6 to the 3rd power, I realize that I get 216. Okay, so I'm going to bring down that negative x plus 4. Oops, that's a 4. All right, equals. Now, about this fraction that we're not going to panic about. So obviously, again, we're pretending that the 1's not there. Just look at it as 36. So 6 to what power would give you 36? And hopefully you'll know that that's a 2. Okay, well, it is a fraction. So what does a fraction do to a power? What it does is it makes it negative. Remember, when we have negative exponents, we flip something down if it's in the numerator, or we flip it up if it's in the denominator. Now, if you're not sure what I'm talking about, do 6 to the negative 2nd in your calculator. You'll get a decimal value. Now do 1 divided by 36 in your calculator. You're going to get the same decimal value. Okay? All right, so then I'm going to drop down the negative 4x plus 10. Okay? All right, so now let's go to step 2, and step 2 says to cross out the common bases. So we do that, and then step 3 says that we're going to solve algebraically using the exponents. So let me rewrite this. So we have 3 times negative x plus 4. Again, you should be putting this into your notes. And then we have negative 2 times negative 4x plus 10. All right, so why don't we do a little bit of distributing here. So we're going to get negative 3x plus 12 is equal to 8x minus 20. Right? So how about we start by bringing this 3x over to the right. And you know what? Because I'm lazy, at the same time, I'm going to add 20 and add 20. Okay, which will cancel those guys out. All right, so I'm going to get 32 equals 11x. Let's divide by 32. Oh, what am I saying? Silly. Okay, let's try that again. Miss Carter's not dealing with a full deck here. So let's divide by 11. There we go. And we're going to get x is equal to, and that's not pretty, but that's okay. It's still right. All right, we're going to get x equals 32 over 11. Okay, so remember again, you need to do a check. So you're always going to do a check in your original equation. And I know this is going to be a little crazy looking because I can't fit it all in, but 216 to the negative 32 over 11 plus 4 power. You're going to plug that into your calculator, and it's going to equal 1 over 36. And then you're going to have negative 4 times 32 over 11 plus 4 power. Now, if you slowly and carefully plug that into your calculator, you're going to end up with 352.1088 on the left, and you will end up with the same thing on the right. So we know that we're smart and we did this right. Okay?